morning, ladies and gentlemen. Can I have your attention, please? We will be starting the event shortly. On behalf of Invigour Energy and Reservoir Link, I would like to extend a very warm welcome to all of you. We appreciate you taking your time off your busy schedules today to join us. My name is Terry from Invigour Energy, and I will be your moderator for today. Before we started, I would like to remind all of you to be aware of the webinar house rule and that we have displayed on the chat box. Now, I would like to give a little bit of introduction about the topics that we are going to discuss for today. As we all know, brownfields are continuously exploited for maximizing and optimization of productions. Considering today's environments of limited ability to invest in new developments of oil and gas fields, today's topic will give considerable insights on how to maximize production given the situation of formation damage. Most of existing fields have been producing for more than 25 years. Therefore, the decline in production and flow assurance problems are inevitable, and they need to be tackled before production optimization can happen. A proper diagnosis process is particularly very crucial to understand the issues faced by the field, the wells, and the topside facilities. With the correct diagnosis and proper treatments practices, corrective and possibly preventive measures can be implemented. To many engineers, it is important to understand not only the challenges, but also the available options in the market for both diagnosis, processes, and the solutions to the problems. In today's sharing sessions, we will be discussing on some of the common myths and against the realities, and also the pros and cons of prevailing options to address the issues. And lastly, we will be also sharing some of the few case studies. Now, without further ado, let me introduce our speaker for today's event. Let me introduce our speaker, Anwaruddin Saidu Muhammad from Reservoir Link. Joining us with 16 years of experience in oil and gas, he is currently the Chief Technology Officer in Reservoir Link Energy. He held various positions and functions in applications in the sectors, primarily in hydrocarbons productions and reservoir recovery. Hello, Anwar. Welcome and thank you for joining us today. I now pass the floor to Anwar to share with us his knowledge in the subject.
Thank you, Thierry, my dear friend Thierry. Thank you so much. Thank you our partnership here, and thanks Invigour Energy to continuously work on several areas with us. Finally, I have a little bit of time to do what I'm passionate about. I've been actually very busy with lots of initiative within the organization. So, I've really felt that it's about the time to start sharing the knowledge I've obtained and the experiences I've learned through the past years. And therefore, I would like to thank all of you who are attending this webinar. Now, the intent of the webinar is obviously not to make you an expert in the formation damage area, but my material is quite extensive. So I have quite a lot of things to share with you, but I might not be able to touch every single things written in the slide. So please, avoid me of I do not like to read the slides, but you can take the photos of the slide or you can scribe it on your paper. And there's a wealth of information from many researchers, including myself, and also some of my colleagues who have demonstrated great deal of work in formation damage. Okay, let's start up now. Okay, hold on. Let me get the... Okay, it's not moving. Okay, so before we go further, I think I want to energize all of you. Want to have opinion polls about the poll question here. Yeah. Okay, we have one poll question. I think it's a bit of lagging here. Okay, so the fossil fuel, coal, oil, and gas as a global energy source stands at approximately 80% as of now. So what do you all think it will look like in about 10 years to come by 2030? So I'm giving you about 30 seconds. Can all of you poll? I think I'm going to poll including myself. Please go ahead and we will see the answers, and then I will give a little bit of comment from my side. Okay, let's pop up the answer. Okay, that's almost what I expected. Yes, it is. Well, thank you for optimism among the four answers we have got there. 22% of them applied. But most of you have stated 60 to 80, which is quite realistic. In fact, the study has shown that the past decade there was not much changes. In fact, there was about 82 to 80%. That's about 2% changes, right, for the past decade. So I don't. I mean, of course, there's a fiscal policies and energy policies are obviously changing every single day, and around the world. But really, the fundamental science, fundamental physics, and the fundamental of the economy, what going to make a difference. So I don't see that will be a drastic change within 10 years to come. So that means we are relevant, and in fact, our job of providing affordable energy is so important to the civilization of in upcoming years. So please head on, and we are doing a job which is on ensuring the sustainability of the human civilization. Okay, next, let's go through the introduction. Lagging again. Okay. Okay. So let me put it into the basic things. What is formation damage all about? See, when we produce crude oil or even gas, they are only basically, to make it simple, there's a driving force opposed by resistance to flow. Um, can Fazlin take control? It's a bit easier, I think. It's lagging on my side. Yeah, I will just give up the control. And it's I think easier to be controlled at your end. Okay, slide number 1. Okay, so the resistance can come from various perspectives, right? And it can come from various forces that working against our agenda of flowing hydrocarbon as much as we could as engineers, as owners of the asset. So some of the examples are solid deposition in the system. We don't have to worry about it. We'll talk about it in a short while. Changes of pay, rock wettability, and rheology change, and mobiles that is moving and blocking the pores. So at the end of the day, formation damage is simply the resistance for inflow. Inflow means from the reservoir to your well, which is a conduit to eventually you realize the production of hydrocarbon. And this happens because a permeability impairment near wellbore. So you may ask me what is near and what is far. So near wellbore is really near wellbore, something that you can reach out. So that's typically can go from feet to meters, but it's not certainly more than deep, more than 5-6 meters. That's considered a little bit deeper. So near wellbore typically revolve around meters, certainly cut at about 10 meters. So at times it's very difficult to understand and quantify and remediate the issues associated with formation damage, just because it's quite complicated. And in fact, until today, as much as lots of resources available, some of the mechanisms are not well understood and not well established. But obviously, it doesn't give us an excuse to do things without undue studies, a judgment that we able to do a best judgment as engineers. So that's going to be the core of center of topic that I'm going to challenge some of you, especially if you are listening to me from a background of production engineering or reservoir engineering. So the consequences is quite obvious. Obviously, the formation damage, which is a damage to the formation, can cause production decline, or some of you mainly attributed to production deferment. Early water breakthrough, increase in water cut, which is associated with water breakthrough, right? And GOR increase, especially if you're operating an oil asset, you would like to recover as much as liquid from the well. So at the end of the day, the production loss is associated with the pressure loss happening at the inflow segment, as you can indicate beside the picture there. And it can actually happen in any stages of production. Yeah, it can happen at a EOR stage or primary stage or secondary stage of your production. From this, in fact, it starts from the exploration well itself. The formation damage is inevitable at any stage where you introduce or you put, you prepare a conduit or well construct the well until the day the well has the keys to operate, and formation damage can happen anytime, anywhere, any place. Next. Now, I did a little bit of simple analogy of what it is formation damage cost us. So I looked into the public domain of Shell, and it is estimated back then when it was $20 per barrel at 1997, 8, if not mistaken, that was estimated at $1 billion from their asset, Shell asset. And at that point of time, Shell accounted for about 3% of total world production. So, which is about the same now. I think it's about slightly more or less, but it's about the same. It's just a ballpark number. So today the oil price is keep on changing, but I just an estimate of $50 per barrel, which was a little bit of a sustainable number that we have seen in the past years, and it should be about the same benchmark of going ahead. And that is accounting for about 50 billion per annum. So every year, the cost of deferment or unrecoverable, sometimes you can't even recover at all due to the damage, and that's a conservative number of 50 billion per annum. So here we are is justifying that why people like us is required to pay attention to the formation damage, because it's not only about academic, but it's actually real. It really means dollars and cents. Yeah. Let's go through a little bit of a background about formation damage before we go to the next question. So I want you to all stay alert. You're going to spend an hour or an hour and a half. So when you leave this space, virtual space, if somebody talk about formation damage, you have a basic idea what it is all about. So that's something that you gain with you. Knowledge is an empowerment, right? So we have a structure, from the day you drill the well. If you see the diagram at the first one, structural damage, that's a damage that is visible damage. That's why it's called structural. So it's a tubular deposit, the deposits that is formed inside your well. The scales, paraffin, asphaltene, those are deposition that forms in the well or around the well bore. Corrosion products. So these are all visible things. So you can recover. You can actually quantify. As an engineer, you can actually let the well intervention team to recover some of those, and you can study. Perforation damage, which is actually a entity that connecting a cased hole to the near well bore, which is actually most of the asset in Malaysia and around the world are very familiar with. So the perforation debris, this is something that you can quantify by simulation, but really, it's difficult to prove because you're not going to recover those things, right? Mud cake, the mud losses, sand from production tunnel, which is a blockage associated with mobiles, particles from the injected fluids. Sometimes you do injection of the fluid from time to time throughout the life of the well. Pressure-induced deposits also can happen at the perforation tunnel itself and also near well bore. Now let's go to a little bit deeper. We call near well bore damage. So we talked about well, the perforation, which is a connection, and also near well bore. In the near well bore, you have all long list of those. Water saturation, emulsion blockage, migrating fines. So we will have a structure of this mechanism study a little bit later. And you will also have a deeper damage, slightly deeper, which is in the forms of meters, right? The collapsing of formation matrix. Then once you have the collapse, your permeability and the flow pattern is diverted, and that's going to have a problem in terms of production. Water blockage and water coning, that can happen, a little bit deeper into the formation. So the source of the formation damage that we just defined just now, if you see the picture below, that's mechanical, biological, chemical, and also thermal. These are the common way of we can describe a source of the damage that can happen, right? So there must be a chemical reaction to happen. There must be a mechanical and physics associated process to happen. There must be thermal changes, means the thermal energy, heat energy, that heat dissipation, and so on and so forth. and associated things associated with the thermal. So these are the 4 types of common processes. Next, flow assurance. A lot of flow assurance engineer in today's world, one of the major issue we are seeing is that often enough that when we produce hydrocarbon asset, the subsurface team, the people who work on the subsurface and the surface people are often disconnected. That's actually one of the major issue on how sometimes we are not very effective in solving the problem. Now, the flow assurance is very much associated with formation damage. Some of the consequences that you will see eventually when we are not able to control the formation damage or avoid or mitigate, then the flow assurance issues comes with it, right? So, for example, the number of things that you are seeing here is also can be a consequences of formation damage. Next. Now, in terms of mechanism, we talked about the source. The same source also can actually provide the mechanism to explain how the formation damage evolved in your asset, which is in your well. So now, when we tackle and trying to understand the mechanism, actually nonetheless, the closest analogy we can give is actually a doctor diagnosing a patient. Normally, when you go to a clinic, the doctor often asks you questions because you are not doctor to tell definitive answers. So the process is actually a ruling out process, meaning to say that if you explain, I have a dizziness. So you can talk about dizziness, but you wouldn't know why you feel dizzy, right? So then the next question would be, what food did you take today? What is your temperature if you have ever measured? So these questions are actually trying to find out the mechanism that caused the dizziness. And it could be when you zoom down, then only actually you go for diagnosis process. Otherwise, you have to do almost all tests available in the hospital. So when the ruling out process happen means, the impossible causes are taken out. Similarly, when you talk about formation damage, you have to find out which mechanism likelihood that affected your production, and that's sometimes quite sometime even from the production data and some of your well intervention data, you could actually zoom into a particular mechanism so that you don't waste your time to look around so many other things. So that's why it is important to understand this mechanism, on which mechanism that likelihood affected your production. Next. So here you go, our time for the next question. Yeah, I want to see whether you pay attention to the presentation or not. So let's see what are the options below is the type of formation damage. I will let you guys to just participate in the poll and let's see whether some of you or every one of you got it right. Okay, let's do it. Okay, let's see the result of the poll. Yep. Actually, most of you are correct, but it's just that, many of you have got it right. Actually, all of them are actually a particular type of formation damage. I know the gel could be something, okay, yes or no, but yes, you can have a gel formation near wellbore 2 related to bacterial activity or even in situ sledging. Yeah, so that's possible. Okay, next. Let's talk about assessment. So we talked about the doctor. So you already decided, okay, fine, I have a particular mechanism. I think I can understand where it comes from. So you lend your ears and also your ability to see the data to the well. Try to understand what it's trying to communicate with you. The next thing you do is that how can I ensure this mechanism is validated, right? So how do we validate? There's there's lots of good theoretical books available to look into it, particular subject of those area. Now here, what I'm trying to address is that, if you look into, say, an example is that structural issue just now, right, which is mechanical, which is related to deposition. You can see with your naked eye, but you want to understand, how this deposit formed, how severe it is. Then an example of these are LPSA, XRD. This, you can take a snapshot and you study yourself what is it means. But these are collective number of analytics available to actually validate your prognosis. You want to validate whether the mechanism that you talked about is the right one. So you can actually go through this a chart, this possibly all the possible type of secondary and tertiary tier of a formation damage from a high level. I break it down to, just now we talked about mechanical and chemical. I just break it down further, and then we know that there's a potentially two area to study. So one is the mechanical one, which is related to deposition. Another one is actually the solid that you have collected, which is probably fines or mud and so on. So then you have to study further. We have to validate it. So how do you validate? You have to do all these tests. And in fact, if you don't have much budget to work around the area, you can actually get expert opinion. Because sometimes some of this damage have certain signature in terms of production and well behavior. The pressure losses, in fact, you can do pressure buildup to do a matching between other wells. So basically, history matching could be another example to help you to minimize this work, and you can actually minimize probably 50% of this work. Then you can zoom into the amount of budget you require to spend on all these tests. Next. So often enough, it is always, as I said, if you have formation damage assessment and say that some of the mechanism is well understood, and you need to correlate and corroborate with your flow assurance and topside engineers. So that gives you a wealth of information, because there is a science and physics behind how a particular damage should behave in the well and topside. So please always try to map it against the flow assurance issues that you are seeing in your tubing during your intervention or pipeline or any other flow conduits that flow assurance engineer or production engineer dealt with. Yeah? Next. Now, we talked about the prognosis just now, right? So how do you do the test? You have to have something to work on, right? So for example, if I walk into the hospital and I have problem, often enough that I have to make sure that people are able to study me. So what do I have? I have, I can get liquid from my body. I can get the blood sample. I can get tissue sample also with the latest technology. I can get a urine sample analyzed. Similarly, in a well, you have a similar situation here. You can get your crude oil to be analyzed further, trying to zoom into what we just discussed. You got deposition coming from the well. You've got water that produced from the well. Mobiles also produce. Mobiles could be any. So fine, sand, clay, any of those. You can also have a bacteria debris, which is slime, for example, you can collect from the well, and you can study them. And in fact, after all the study, what do? You actually, many people often enough, they kind of do not understand why they're studying, but they just study because it's what SOP says in their organization, right? But the value of us is to actually understand why we are doing the study and how does it corroborate. And we selectively choose what we really need to study. And then that means when you study, you want to understand the nature of issues, which is whether that can be associated with the issues that you actually see. If you talk about excessive sun production, then it must be coming across, whether it's related to unconsolidation of the pore matrix. So you're doing core analysis to study that, or you want to understand what kind of sand and what are the size of production, whether it's coming from deep reservoir or near wellbore. There's also associated to the sand count and also the size of the sand and fines. So those are how you have to develop a proper matrix of how you zoom into the problem. And you also have lots of a great deal of things done by engineers in the past, and of course corporate suites available from the companies in terms of analyzing this. You can take the data from this and actually analyze in various type of softwares and finite element analysis. So some of these are actually highlighted here. And finally, you want to check and you have to design this design of experiment to understand that you should not be surprised of things happening. For example, if you're drilling a well, you're exposing a well for your mud, and you have signed off the mud recipe, you got to make sure you have to understand what it can do and what it cannot do to your formation. So that design of experiment is very, very crucial and need to be documented, need to be properly done, so that when you later on see issues with the well, you know where to refer to. I have gone through many example in my life and in also in my paper. Some of it I've highlighted. In fact, the data archive is one of the real thing that we need to improve as engineers. Sometimes wealth of information were done, but it's not properly documented, and therefore you could not tie back. End up you have to spend money doing it all over again. Next. So we have workflows quite established. Actually, sometimes it's very proprietary too. For example, with the help of my staff, in fact, through my experiences, through my past acquaintances with organization, I have developed quite a number of workflows to make my life easier, right? When I deal with customer, to ensure that I try to recommend them a particular workflow to identify without exhausting their budget and also time. Time is also another essence. If you go around and study, it could be a exhausting experience of just all about research. But here we are talking about finding solutions. So please, we have to take that into the to account, and we have to zoom into a particular workflow that is acceptable and it's actually geared towards finding the solution, right? So these are many of the workflow. For example, these are emulsion. How do you deal with the emulsion? Next. How do you deal with the scale characterization? You can characterize the scale. There's a particular workflow you can take into, and it form a part of the guideline. Next. You have organic deposit that you can actually deal with. You can also have a very much of a workflow that works for you. In fact, you can have your own workflow based on localized to your environment that you operate. Next. And finally, some of these workflow, I have also developed and amended a particular ASTM standard and these are specific standard, right? A specific indicators you need to work out. You need to ensure you have access to SPE publications and ASTM publications and API publications to find out some of these quick numbers to guide you to the right direction. So one of these is, for example, SARA analysis. For example, when we take a blood check from us, trying to find out whether there's sufficient and balanced white and red cells. That itself will tell you a lot of story whether you have infection or not. So similarly, this is a very similar example of how you can actually characterize your crude oil and check the balances between the good one and the bad ones, and eventually come to indices that helps you, are you doing a balanced health check, or if your health is poor, and then you can go further. So this is available from the SPE paper. If you can see the SPE paper, please take note, and then it's useful to you as a first defense of analysis. Next. This again of sand and fine migration. Well, fine migration or mobiles migration is one of the most arguable formation damage as of today. Actually, until today, there's not established practice of telling how much it account for in terms of blockages and how does the fines migrate. So because it requires lots of study, it requires continuous monitoring to understand, how much fine produced, how severely it produced, what are the sizes from time to time, because this going to make a check and balance to your laboratory analysis, and that is important. And because with that, you can simulate the issues in your core to actually pass through the similar kind of characteristic of fines with your water, and eventually you can do the same. You can study those. So we got to a third poll question. Now let's see. It was a fast one just now, but I hope some of you would be able to, even without seeing the material, should be able to tell what it is. Okay. So which one of the below is not analytical laboratory testing? You actually do the testing. So which one of those is testing and which is not? So which is not is the question, yeah? Okay. Let's see the result. Many of you got it right. Actually, yes, Langley index calculation. You actually get the analysis done first. And then based on the saturation of the cation and anion, you can actually, and some other parameters, you can actually calculate Langley index to indicate the saturation of your scale in the fluid that you're concerned about. The rest is all testing. Acid and solvent test, you actually do the lab testing, and XRD is analytical test, SEM is a test, but Langley index is a analytical calculation. Next. Formation damage mechanism. I will not dwell too long into this because I just want you to know that how the mechanism is. Some of the main one I will try to highlight. Okay, next. Excuse me. Okay, first and foremost, formation damage does occur during well construction. Actually, in public domain, I have seen many exploration well that with the formation damage has caused engineers, geoscientists, and geophysicists to interpret lower producibility from the reservoir. And because of that, the economics numbers has been not well reported, and some of this has been bypassed. So that means the formation damage can alter your decision in a great detail of actually whether you want to go further for development or not. That's how critical it can be actually. And this is not a theory, but it's actually already happened. I would not want to name the name of the client, but of course it actually already happened. And now it's being revisited again to understand the mechanism and try to uncover without the damage, how would it be the formation, the producibility of the well, which is exploration well or appraisal well. Then you can decide on the development. So it can happen in the drilling phase, where during the drilling, you actually introduce alien fluid, and that means the drilling mud. And the drilling mud will have a filtrate that connect to the reservoir. And this alien fluid is not same as a native fluid. It's not going to be compatible anyway. So you have to make sure very little amount that's passed through, and that's mean your filter cake must be a good one, pliable and thin. But sometimes it is not able to control this, then you have an invasion. And you can actually demonstrate this and test it out before the operation of drilling also actually. A good mud engineering practices would be able to detect the issues beforehand. And you eventually have engineers onshore, offshore to actually monitor any deviation from from the project, where the quality of the mud and so on and so forth, right? That's very, very, very crucial. Completion phase, yes, also potential, where completion is very, very important, because the last step before you uncover or recover your hydrocarbon, and whether you perforate the tunnel, and that means the completion brine going to be interact with your formation, or in open hole, you still have the completion fluid interaction. So it is so crucial that you take care of how that interaction cause damages, for example, clay swelling. And the water activity level in your completion fluid and the formation is need to be matched or exceeded in order to have little swelling or almost no swelling. That's very important, because some of these are not reversible. There are some innovative fluids available now, but some of these swellings are completely irreversible. So that's how important is mechanical damage associated with the completion phase. In fact, there are perforation which go deeper, but sometimes you can realize a lot more if you don't create this damage. Next. Now, during production, there's lots of things will happen in your production. As you operate your well, you will have changes in temperature and pressure, which is here in this. Is a very classical example of a phase envelope. And the phase envelope during your production, your exploration and appraisal and production, these knots going to change because your pressure going to change, your temperature going to change. That's for sure. So, and also during the ascent of hydrocarbon from the wellbore, which is near wellbore, to the tubing head, you have a deliberation of light ends, like your gases will deliberate out. So your heavier ends will be separated out from light end. That's also another potential issues, because the light end is actually solvent and the heavy end is actually a solute, and you have a solution which is hydrocarbon. So your solvent is separated from solute, and the more the solute, you have a saturated wax and asphaltene potentially could come out. You will have other type of interaction also. Your pH changes in environment due to deliberation of CO2 and that means the pH can tend to be alkaline, which is not preferred, and the naphthenic acid can be destabilized, for example. You can have the cationic and anionic exchange can happen, where during the production, your water can also start to come in, and these anion and cations carried by water can have certain certain impairment also, can cause certain impairment, and the issues associated with the organic deposit can cause wettability alteration also and change your relative permeability, and this water production also often have effect of erosion or destabilization of the formation, where your fine and sand can start to be produced. And obviously, this excessive water and sand, which is unwanted fluid and solid, does not contribute to your operational efficiency and your revenue. What you want is hydrocarbon. So your OPEX can increase as you produce many of these. So that's the mechanism during production. And that means next, you are going to deal with some of your wells associated with asphaltene, but it's not all bad news. There's lots of technique to understand how it produced, and also actually to some extent you can avoid, but some you cannot, but you can minimize, right? So asphaltene, you can research into your own self. It's very common in light oils, because the fraction of resin and aromatic is important to stabilize the asphaltene. So when you don't have enough of those in the light oils, then this asphaltene is easier to come out, and it's a colloidal nature and can sometimes become very nasty to your well, as well also formation, to your topside operation. It can also cause wettability reversal, and this also can actually poison refinery catalyst. So of course, it manifests as a skin in your near wellbore if it is not properly controlled, and obviously you will have a production loss. Next, wax. Wax is a very classical example that is misunderstood until today. One of the common mistakes that people do, people often tend to ask and design the well according to field development studies associated with the particular field. And people often ask, if I operate my well above WAT, what's the problem? Well, it doesn't not necessarily solve your problem, because the wax can evolve during your production stage. And it doesn't mean that just because you already well understood and you have you already anticipated the production numbers to be quite above, and the WAT is very high. That means you can produce you require much lower temperature to produce the wax, but it doesn't mean that you're not going to have problem associated with the wax, because during the changes of the subsurface condition, you may have microcrystalline wax that can actually can be produced, and that is actually can have very high melting point, which is the high molecular chain microcrystalline wax, and that can exceed 100 degrees Celsius. And when that happens, even if you operate the well and you already say that my WAT is only 20 Celsius and I'm operating above that, which is about 60 Celsius, why am I having problem? Well, you can have a problem at near wellbore still, and that still can be related to the wax. So do not use the field development numbers as it is to rule out. You have to really drill down deep to the latest information available and latest practices to tackle and understand, if you have wax associated issues. And this deposition of wax can cause enormous issues, especially if you operate heavy oil or waxy field. There are a number of those fields in Malaysia without naming them, and it is important to understand how this forms. Yeah. Next. Naphthenate is another very specific issues. I used to deal with this in Brunei back then. It's a very niche envelope, envelope that has its own. Sometimes it comes in and then actually goes off by itself. But I'm not sure whether many of us can actually, tolerate the time where you have to face the naphthenate and the deferment related to production and flow assurance issues. The naphthenate issues are associated with the natural naphthenic acid in your crude. that is actually something you cannot avoid, but every crude has its own definition of how much of this acidity is there, and some are a lot of acid, some are less, so defined by 10 number, total acid number. And when it interact with saturated ions such as sodium and calcium from the water, then it form metal naphthenate or salt naphthenate. And then that's when the problem starts. So there's nothing wrong with having naphtenic acid. You can have them. All crude will have naphtenic acid. You can avoid them. You cannot avoid those things. But you have to see how it interact with the calcium and sodium. And once it form, it is very, very tough to remove. It is neither solved by any solvent, mostly, or any thermal method. That's also not applicable for this. We call it plastic wax, but it's not wax. It is neither organic nor inorganic type of issues. It is by its own, and it is amphiphilic molecule. Yeah, it is either water or oil related. So this is something you need to understand more if you deal with, and you can detect these particular issues, which will be a case study that we'll talk about later. Next. Inorganic scale, very common one. You can actually see a scale in your water tap. Not that difficult to know what scale is all about. In our drinking water, after some time, your pipes will get blocked. Actually, that is actually a scale that blocking the water, and it's come from water. So that means the inorganic scale, you have to produce water in order to have inorganic scale. If you operate oil well with 100% oil, then you shouldn't have these issues, right? And some scale are very straightforward, some are very, very nasty one. And scale associated, probably I would say one of the most common formation damage, and as well as flow assurance issues in Malaysia, and I think many countries. It can happen in your near wellbore, it can happen in your conduit, which is wellbore itself, tubing and so on, and as well as topside. And this is obviously due to lots of things related to pH, salinity, yeah, temperature, and so on and so forth. This can be characterized and as well as understood quite relatively easier compared to others. Inorganic chemistry is well-established chemistry in oil and gas, but one of the difficult one is that some scales are not easy to remove. That's and it's expensive to remove also. Next. Mobiles, when you produce, the problem with the mobiles is that you can produce them, but some of these mobile, when migrate to a smaller port throat, it can tend to block. That is the problem. And other than that, you can have erosion related to mobiles, right? Sand and silt cause erosion in your tubing, and you have to continuously surveillance the tubing healthiness, whether it's the poked hole, and then you can have integrity issue, right? The well integrity issue is actually a problem related to the something that costs a lot of money to repair as well. And same thing for topside formation. And as to date, in Malaysia, at least I think sand, silt associated production could be top 10, production deferment related issues. We got to close down and choke the well or reduce the production just to minimize the production of sand, silt. And fine and clay have a different chemistry mechanism. This has charges. So often enough that these charges are actually similar and they repel each other. That means it's kind of you have to understand the chemistry to control it. And either erosion issues or your production loss issues also can be associated with mobiles. Next. So we come to last poll question before we go to the last section of my presentation. So what is below is not an organic deposit. Actually, we just talked about it in my third or fourth slide just now on the section. Let's look into your answers. Okay. Let's see the results from the audience. I think all of you, most of you got right. 74% of you. Wax is definitely organic deposit. It is come from the organic nature of the crude itself. So the wax come from crude oil. Asphaltene is also from the nature of the crude oil. So what it means is this wax and asphaltene come from crude. So if you want to mitigate, you have to focus on your wellbore. There's no much you can do. You cannot change your crude oil. That's given by God. It is inside your reservoir. So you have to find mitigation related to chemistry or mechanical and so on and so forth near wellbore. Okay, next. Impairment and estimation. I think this is probably the last section before we go to case study. We'll do very quickly. Next. So you can actually estimate the formation damage. That's not a major issue. We do have very good practices around. That's a very straightforward calculation on understanding. So we talked about formation damage. It's impairment to your permeability. That means you have to understand how much permeability reduction happened, right? You will have your initial permeability that you already accounted for. Now it's impaired. So you will have an altered zone equivalent to the the effective permeability and unaffected region. So often enough, this altered zone, we talked about the near wellbore, right? Which is can be foot or the meters to the meters. So it can be calculated. And the skin is the terminology used in oil and gas to define how much impairment it can be. So we call it skin effect. And the skin effect could be a cumulative of various type of processes that the type of damages we talked about all the while. It could be due to completion, perforation, phase changes, and so on. And the collective skin is the total skin. And when you operate, the higher skin means you have losses in production. Ideally, you can have a zero skin, ideally, but I think that there's no such thing as ideal in any environment. There is no 100% efficiency to even Six Sigma, it's 99.99996 or 8. Yeah, I can't remember that. But there's no such thing as idealism in anywhere. So there's no zero. So let's live with it. But you can minimize the skin, right? You don't want to have 3,000 skin. You don't want to have 24 skin. You want to have as close as possible to zero skin. That means you have ideal production coming from your reservoir. That means your drawdown is maximized. The unit of barrel produced, which is output, versus the delta P, which is unit of input of the of to the production, is as maximum as possible, which we call productivity index. Yeah, we want to maximize the PO. Now, what does it mean by negative skin? If you stimulate the well, you remove the permeability, but you also can fracture it. That means you improve the permeability from original or from impaired one. You can actually have a negative number. That means you improve the production from what you even have a technical potential. So this is a damage estimation. I think this is something most of the production engineers do. But I have seen places where people don't do anything, just simply do acidization without any estimation. I think that is not right. We have to do it. That's a judgment we do. It's an ethical question we have to ask. We cannot do things that we cannot engineer, because as engineers we have obligation to our subject lines. Next. This is one classical example. So please understand the substance before making decision to remediate. Before going after the vendor to ask about, I want your fleet to remediate this issue and so on, what proposal you have, try to understand what's the depth of damage zone that you are encountering for. This is fairly easier to plot. You can have a production after the damage and original productivity. You can plot one of those classical example, and how far it is goes towards that. So if people come out and give you a proposal, look, I want to remediate 5 meters behind formation, but your judgment tells that what the major problem is only after, if you see most of this curve is kind of taper off at 24 inches, which is about 2 foot, right? Especially for damages related lah. We're not talking about water and so on and so forth. Water is deep inside, but we are talking about damages, let's say structural damages just now. So if you already know 24 inches is about the maximum privilege, maximum return you're going to have, so anything more that you spend is just not that incremental. So therefore, it's important to identify, what depth of invasion and investigation you want to do, and at the same time, this same depth that you want to remediate. So that's very, very, very crucial for you to understand this. Next. So the formation damage estimation, sometimes you also need to understand that the major contribution usually come from reservoir, 70 to 80%, or your sand phase. When you have the manifestation of this as a flow assurance issue, and those are usually account for 5 to 15%. So you immediately know where your focus should be. Next. Now, this is a classical example of you telling you a pipeline related issue, right? if you have an even distribution of the solid, same amount, and you can have only 10% throughput reduction. But uneven deposit, due to changes in flow pattern, can actually have a 35% throughput reduction if your pipeline is on the maximum throughput lah. And of course, in order to get back to your throughput, you gotta compensate with the pressure, operating pressure, 35% for even deposit and uneven deposit 140%. So for flow assurance engineers, I think this is very, very important aspect to look into. Do not ideally simulate that in Olga and expect the same result, because you have to understand how the deposit are distributed, and it's the effect of it may be a localized deposit in the pipeline compared to uniform. So this non-ideal situation has to be understood. Next, let's go to the final section. Industry approach. How do we solve the problems? Okay, first and foremost, you must do your very prudent analysis on your data. If you don't have data, I tell you there's so little that you can do. And I also have lots of people coming to me now. Uh, they would like to remediate, but there's nothing much they can do. They don't have fluids, they don't have deposit sample. So for example, if you go to a doctor and you say you have a cholesterol, you say you think you have a cholesterol problem, how can you prove it without taking a blood sample? And if you don't prove it and understand what's the level of your cholesterol, for example, well, I know there's a research now in US saying that cholesterol is not bad after all, but just imagine that I don't read it now and I'm looking behind myself, right? So assuming that cholesterol is all bad. So whether the dizziness caused from cholesterol or not, how do we know? We don't know. And that means you just simply look into marketing companies coming out with all these energy boosters, vitamins, and cholesterol reducers, but we don't even know what kind of cholesterol we have. So that is so important to actually have the data in place. So do not feel, for people out there, I know it's a bit difficult to go and search for data and things like that. But you know what? It's a lot more wastage to spend millions without having the right judgment to the well, and you don't get the treatment right. And then eventually we turn back and say the service provider or the technology provider did not do a good job, because the technology is depend on how you apply it and where you apply it, where is the right match. So that is why this workflow is very important. You understand your reservoir data, you understand your well data, and you do certain estimation. There are so much techniques available before actually go on and do the remediation. Next. Now, there's a structured way of undertaking this. Many people go straight to implement, want to just implement straight away, right? Of course, I like to replicate too, but I have seen places where two well from single reservoir, one have one particular issue, and it's not too far, probably about less than 2 kilometers away, or less than the final reach is the whole area is just about a kilometer, but totally a different issue. There's another well is having the issue relatively totally different issue. So why is that? Because of the inherent complexity related to how the fluid move from a source, migrate, and then eventually produce to the well, and it comes through a different flow pattern, and it carry different issues, and probably the pressure domain is different and temperature domain is different, and even though your completion is exactly the same and the well is exactly the same, you can have a different problem. So you need to study those. Therefore, you need to have a structured approach to this. Next. We talked about this just now. So in one of those, for example, there are tools, but it's not a very generalized tool. It's a specific tool to certain issues. You must have access to them. If you don't know the existence of those tools, I think you will, you may not be able to have the very high success rate, right? This is a tool we're talking about how to analyze waxes. So it's a particular index that tell that whether it's a healthy or non-healthy. So where the waxes are like a sugar and solute is a water, right? Here, the resin and aromatic is behaving like a water, and the sugar is a saturate and asphaltene. So you must have enough water to suspend those. So you must understand whether it's coexisting in a balance or not, just like our white cell and blood cell. So there's indices to tell whether it's stable or unstable. Next. So this is another example of you plotting the result for different well and trying to understand the acid number and potential naphthenic issue. So you have to have certain parameters to compare with. And as you can see, asphaltene, you can see totally different, right? 3 different well, same reservoir. One is 0.05, but the rest is much higher. So this is what I was talking about. Next. Now the instability also have indices to help you out, whether to, this is based on parametric study around the world. So you have ratios to help you out to understand, the stability of you operating the well. Next. Lithology is another area. You can also have all this information from the exploration well and development well. And you must understand what kind of lithology you have to understand the risks associated with swelling. Some clays are very sensitive, some are not. You must understand the ratio of these coexisting so that you design the right treatment without damaging the wellbore. Okay, next. This one classical example, the left you can see is a matrix with a micropause originally, and the right is actually, on the left is the original, the right is tested with filtrate. With a naked eye, you can tell that actually is already damaged. All your micropause is already blocked, and that means your permeability can be compromised. And this is a gas well. Next. So you can do a production analysis of if you are conducting a very effective remediation, and what will be the improvement. You can actually prognose that with a inflow outflow curve, and that will give you an indication of how much improvement you expect, and that must be matched against a practical experience from the well too. Next. We also have lots of help from simulation, computer aided tool. What you see here is a perforation tunnel. You can see the final element analysis give you insights of, if you can see the left one is here on the right, where you see you have a red color, is completely not damaged. On the right side with the color contour is damaged. It tells you the pressure response, and that means you get a wealth of detail of, let's say only one perforation tunnel is blocked. What will be the situation? How will be the flow? How will be the pressure distribution? So you can zoom into the what do you call it, remediation quite accurately. Next. So remediation technique, we have lots of technique available in today's market. For all of them, many of them are matured, but some of them are emerging areas. So it is always good to work with the universities and also startups, research institution to actually develop your own. But some of them are already matured and available in place. But very importantly, it's not about how mature the solution is, about selecting the right one to your environment, to your well. That means you need to do diagnosis and prognosis in a way. So next. So this is just a classical example industry solution. You have a screen, slotted screen, which is to control your, and they're self-vibrating. So that means fines can be controlled. Fine usually stick those area, and then eventually your sand removal become blocked, and then production also decline. So that's a classical one. You got a wax cutter in the middle. You have a, a jetting tool to clean your pipeline. You have hydrocyclone descenders to remove sand and fine. You have a flow tubes, we call it, to minimize the production of scale. This can be installed in the well. So these are all the type of innovation. Next. Finally, the case study. Okay, next. This is a classical example of what I have gone through. This is what I've done personally. I've actually papered it in SPE. So basically, to put it simple, there was a well. Was been producing 20 to 30 barrels from the day one. This well is supposed to be a prolific well that's supposed to produce about 1,000 barrel actually, or range of 800 to 1,000 barrel. So immediately everyone tried very famous chemical solution from very famous companies too, and this was applied. But the problem with that is there was no diagnosis done. So it's all about trial and error, right? You try, and then there's millions has been lost, but nothing happens. There was 2 or 3 attempts. Our approach was actually, or I would like to actually put a lot of time to ensure that I team up with people to study those areas, to ensure that drilling damage is understood, which is from drill in fluid, which is right before the completion, and any other diagnosis method available. So we collected the sample We study them quite in close view. We found out that actually it is not an inorganic issue. We had a lots of organic low concentration of corrosion product. We also had a low molecular weight organic, but the crude oil that we collected had a lot of quite a substantial TAN number, total acidity, yeah, total acid number. And the solid itself not sharp melting, so that gave a lot of information just from that alone. Next. So we tried to find out how much organic and inorganic in the solid. So the inorganic are not really related to calcite, but other things, right? So the organic, which is like for example corrosion product and so on. We have a lots of organic. We also identify that actually the naphthenate solid, even though it's a small percentage, it could be a big problem. And we also have a quite a substantial microcrystalline wax. So microcrystalline wax will have a high melting point, not sharp, embedded with the naphthenate. It can be a glue near your elbow, and you will not respond to your acid. You will not respond to your thermal treatment. You will not respond to any solvent wash too. That's why many of the cases are not able to remediate the well. Next. So what we did, we already zoomed down. It was a microcrystalline wax and naphthenate issue, and we had to solve those issues when we came out with our. I came out with a suggestion to do a micro emulsion solution that actually have lots of species in the solution to tackle different type of species here, which is microcrystalline wax and naphthenate. So the design of experiment was very thorough to understand how does it behave with the formation and the lithology, and whether or not it can remediate the damage. And so true enough. Next, please. And we pumped only near 2 feet near wellbore. So we remediated 2 feet because we did the study and we only saw maximum of 80% removal with near 2 feet. But if you go 20 foot, you got another 10%. So it's just that a lot of money to be spent just to get additional 10%. So we just stop at 2 foot. Next. Next. And this is how it was pumped near wellbore. Next. Next. And then near 2 foot near wellbore, a solution was deployed and then remediate. Next. So for very short soaking time, this is the magic of chemistry, right? Okay, next. And then we produce back. So the operation is just a day or two. And that's it. Next thing going to happen is, there you go. You got many years from the exploration stage, from the production stage, many years of attempt. This little jump in the green was a loss of trial. So 20 became 50 barrels per day, right? But can you see 2014 there? That was a huge jump to 800 to 900 barrel oil per day. That's very big. So that's something already presented in SP paper. It's available in public domain. I'm the writer, so I'm authorizing myself to publish this. So there we recover quite a big, and the treatment ROI was just 2 or 3 days. So within 2 days or 3 days of production, you got the money back. After that, you produce per annum, and the little drop after 15 years was a control of the drawdown, and nothing related to formation damage. But I'm not sure the status of this well, but as far as I remember, it was producing for several years. And I think now I heard it's about 500, 600 from several months ago. So that's a huge gain and also benefit of doing things right. Okay, next. So there are some emerging technologies, just to name few. Fine coagulation. How can you coagulate the fine to remove? There are certain, there's emerging technologies now. How can you capitalize on the charges related to fine to make them coagulated so that you can remove better in the top side? Maybe descender. Next. And we also have a scale deliberately being formed to plug certain part of the high water producing zone. And these are temporary barrier but last longer than the polymer. This is an emerging area too. Next. We have a downhole separator. This is always has been developing. This improved further now to become slim and slimmer, so that small tubing can also have. So that means you don't have to deal with lots of water on top side. Next. Conclusion. Formation damage is a multidisciplinary engineering. You already see the things I talked about may connect to many of you in many things, mechanical, chemical, physics. So it's not, that's why it's a job of a engineer, not particularly. So my background is petroleum engineering, but my undergraduate was mechanical engineering. So it is quite critical to pay attention, meticulous attention and understanding. Otherwise, you're just wasting your time and also the budget. The solution can be challenges, but can be properly selected if you have the right diagnostic process and also the right inference by the right people. So prevention is better than cure. You can see that how many years was that? What, 7 years has been producing 50 barrels per day. Can you imagine what happened to the well ROI as well as the NPV during those days? Must be negative very badly, right? Because it's contributing to your OPEX. But if you have understood it well, remediated maybe during the stage of your completion or right after completion, you got all those 800 barrels from the very first day. Yeah. And it is important to integrate subsurface and surface practices to have a final good conclusion for your remediation, and various practices from other industry can be adopted. I think that conclude myself. I think I did in 1 year, 1 hour. I tried to rush it a little bit, but I think you can get back to me through LinkedIn. You probably can take a snapshot of many of the material I presented. It's a very good material actually. In fact, my wish is to publish some of this in a journal or a paper or uh, a book with the collective experiences from other great minds too. Thank you, all of you. So it's a Q&A session. Let's talk about it more. I want to chat with all of you.
Thank you, Anna. Thank you for the very good suggestion that you gave us. I think we have heard a lot of insights from you regarding on how to diagnose, how to troubleshoot, and how to apply the right solution to the issue of formation damage. Now we are going to have a Q&A session. We will address any question that we have received through the Q&A chat window throughout the presentations. We may also use you may also use the raise hand features to ask questions directly to Anwar and to our team. Our team will unmute your sound system for you to speak. Before I read the questions that we have received from the participant, I would like to kickstart the session by asking our speaker's opinions, Mr. Anwar. So Anwar, we know that millions of ringgit will be spent on well interventions, but there is no assurance that the enhancements will be successful. We also know that it is not because the contractor is not doing bad jobs or good jobs, but it is how the engineer take the journey forward. The engineer does not believe in the diagnosis process itself and not familiar with it. From your experience, what is really lacking in the industry, and how can we ensure that the value in our investment can be improved? Thank you, Anna, for the great insight. So we'd like to hear from you.
Yeah. Okay, I have some question on here. Some of you want, first of all, some of you want the material, right? I can totally understand that because I can't go to the great detail of all the things that I talked about. But it's intent to you to know that there's some of this you need to know, right? As a production engineers or operating in oil and gas, operating oil and gas well. I will clean this up and I will let that to be able to be downloadable from LinkedIn. I also thank one of you who actually mentioned this, and I'm going to put it in the slide also. We need to give credit to the right people. I did give credit to some of the in my slide. I need to give credit to Farooq Chiwan, who is actually published Formation Damage Fundamental Modeling and Assessment. When I learned particularly a lot of those, that's my book for the many years. I've been using this book for almost 14 years now. So some of this material, my ideology actually come from him, right? So thank you for that. I will put it that. Okay, and our team also will send the recording of this material, so you can actually refresh it if you want to. I'm not sure whether we'll upload it in the YouTube. Okay, let's look into a question.
Okay, thank you. So let me read out the questions one by one. Okay, so the first question that we have is there a signature formation damage with regards to carbonate reservoirs?
Actually, the damage mechanism here is also related to how your permeability and porosity system also, carbonate reservoir you may have double porosity, of course, got fissures, and then you may have triple porosity. But if you zoom down to a particular damage, say I give you an example of waxes. Waxes do form in carbonate reservoir because it's depend on the type of fluid, right? So the waxes are actually it's a layering process. So layering process here means no matter it's a carbonate or a sandstone, regardless, it actually cementation or say deposition over layer by layer, and each layer attract the subsequent layers, right? So because it's layering process and it happen at a pore channel, a pore throat, so it take time to build over a period of time. But usually a signature related to wax is number one, you actually already get into the operating envelope of waxes. So you may have some sudden signature of something starting to happen. This is an example of wax alone. And then the decrement will be gradual, depending on so your mechanism, you must understand whether it is happening in the tubular or formation. If it is formation alone and you don't see anything in the tubular, can happen also. I've talked about microcrystalline wax, right? So you operate the well with a high temperature, you don't have much issue with microcrystalline wax, but you have a microcrystalline wax. So the signature in the microcrystalline wax in any well, for example, will be very gradual. And if you talk about organic deposition issue, which is you analyze from your crude. So therefore, in the production profile, you actually can see certain level of decline rate that is not natural, but it's not too low also. And that give you some signature of, okay, I have certain type of organic issue, but it's not all macro, it's micro. So sometimes I use this kind of judgment quite a lot. Yes, I agree with you. There are some signatures of production curve for each type of formation damage. Fine migration will be sudden drop. In fact, actually, that means it's migrating and blocking certain space, and there are other spores which is bigger, so it can pass through. So that means you will have a sudden drop and stabilization. So that is a different kind of curve. So the production curve do tell you a lot of wealth of information. So that's basically the answer. Yeah, I hope it helps.
Okay, that is very good. So we've got another questions, and this questions is related to horizontal wells. I think the question is asking, is there any formation damage that is unique to horizontal well apart from vertical wells?
Good question. Horizontal well. Very quick answer. I may have a lot answer to this, but I just going to give one example. Well, horizontal have a severe dot lag, right? I think we all know that. So during drilling, it's not easy to clean, horizontal well. It's very tough to clean the well. Importantly, if you look into well construction stage, you drill and you hope that the mud will be pliable and thin and so on and so forth. Sometimes you don't have a control of that. And very importantly, usually now breaker practice is very common. You have to break the filter cake and also remediate the near well bore before you resume production. Now, the breaker itself is so difficult to operate in a horizontal well, but there are technologies from very prominent companies like Baker, which is very much evolving. In fact, I used to be operating in the environment. I involve a lot in breaker too. So it's a very much evolving area, and your sagging of solid can be very prominent, and that means your cleaning efficiency is very challenged in horizontal well. What is the issue? The issue is that you will have difficulty to remove this or remediate the solid invasion and filtrate invasion in the horizontal well, because the gravity may function. Your straight line, your gravity gonna push it towards the invasion on down deep. So that means your open hole section, certain section can be compromised. So you have to figure out what are the other alternative of advanced breakers to remediate that. So that is more commonly associated with horizontal well. And of course, other than that, obviously, the influx issue, the pressure domain of the horizontal well, right? So you can have ICVs and also other smart well system to actually operate, more gradual production from across the horizontal well. That is your completion technique anyway. Okay, next.
Thank you. The next question is regarding how do we tackle sand or fine migrations, in particular in gas wells, especially with issue like velocities and hotspots, especially around
Okay,
the
this
conditions.
very emerging area, but actually I'm working on some example for this. Actually I'm consulting some clients related to this area, so I can actually have some ideas on this also. Gas wells, your of course the gas production rate is very important, so you must measure. If possible, you can have your studies in the core to understand the critical velocity, to understand where at what point you can have the issues. But if you already have issues, you actually have options available. Yeah, you do have foam based surfactant and gel system that can actually help you to stabilize the fines. You can do that actually, and there are certain surfactant which actually can help you to do that. And there are also emerging area where the chemicals are trying to have effect on your charges associated with the fines. The fines are all repelling charges. So then these coagulations are actually trying to help you to provide additional charges so that these fines are attractive to each other. When they attract, they stabilize better than actually flowing out and plug elsewhere. So this is something emerging area is worth exploring, and actually some of this sand control technique has been applied in gas wells, and it is successful also to remediate the sand and fine. I do have example of SPE papers. Some of my, I do associate myself with Mr. Allen from France. He was ex-Lumberjay, so he worked on that areas, and he did a company by himself, and he's actually focusing on this area. You can connect with me, and of course, I will also connect with him. He have a wealth of information experience dealing with this particular area.
Okay, thank you. The next question that we have is in particulars regarding what are the new technology for solving wax, especially wax issues.
Good. There are some traditional wax remediation technique and inhibition technique. There are also some latest one. Let me go back to the common one. Actually, mechanical cutter, but the mechanical cutter has been commonly used in Malaysia. I used to deal with a field where I went in. It was a mechanical cutter, right? The issue with a mechanical cutter, which is traditional, is every time you cut, the the surface roughness will increase of the tubing, for example, and this is really exposed to the production. And do you know wax? One of the dominant factor of wax production is surface roughness. That means you remove the wax, I understand that, but at the same time, you also make it conducive to produce more wax. That is why normally for wax cutting wells, initially it's very effective. Every 3 months you do that. After that, sometime you become 1 month once. After that, it's become 1 week once, and then you got deal with it every single day, and that's very tiring. So therefore, it is a corrective, but it's not a good strategy actually. So now, what else we have? We have God created us lots of fruits around the world, and there are certain fruits I cannot, develop too much. There are some fruits produce some solvent from the fruits, and these are very effective to treat wax. It can actually break down the wax, and some of them can change the wax morphology from crystalline to amorphous. What it means is, if you change the near bulbo morphology of the crude near bulbo, because the wax take long time to deposit near wellbore, because your delta P near wellbore is the highest, and that means the wax deposition will be highest near wellbore. Even if you focus on removing most of the waxes from near wellbore, it may take years to come again. So what you do, you can actually use these oils, or you can solvent to break it down, change the morphology towards the amorphous, means it will be produced, but it will not redeposit again because it's no longer crystalline. Even if your top side is lower temperature, you operate below WAT or pour point, doesn't matter, it's not going to contribute to your problem. These are good example of the some of the chemicals. People also treat with hot oil and hot water and so on and so forth. But the problem with the hot water is that water is a water. It's not a real solvent for organic deposit, right? It only effect as long as the temperature is there, it actually managed to melt. But many of these that you pass the problem from downhole to the top side guys, and then they're gonna shout with you. hey, what is going on? Your exchanges is going to be filled with waxes, and your separators efficiency probably will be affected. Your pipeline get blocked, and the pigging can get stuck. So many issues. So you have to be very creative to choose the right technology. So hot oil can work, but it's a very limited solvency because the oil itself is not really full 100% solvent, right? You got other ingredients inside. In fact, inside your diesel, you still have a little bit of wax also, right? So you can also have newer techniques. I was responsible in developing one of those area, which is actually in situ heat generating technique. I think in the past, if I remember correctly, BP or BP or Shell was also were developing those things, and I in my experiences I were able to develop one of those two. So it's a in situ generation of the heat where two different chemistries is a base and ester, both are organic species. These are from, as I say, it could come from any as I can't develop too much on formulation, but it comes from fruits. It can come from a ester of the crude oil, for example. Once it mix, it's create byproduct. There are two byproduct. One is a heat positive energy, which is heat, and another one is actually solvent. So this solvent is effective in breaking down the wax, and this heat can instantaneously melt to make the reaction kinetic faster. So this kind of technique is available. Now, in terms of inhibition, I myself very keen to work on this area and currently working on too. With a lot of wax, being something that we need to tackle, there are areas where we are developing inhibitors to effectively inhibit, very similar to scale. Scale inhibitor is actually very immersed area. It's very well developed. Inhibitors for wax also being developed where you actually pump certain chemicals that can be absorbed into the rock, and you can release slowly in order to ensure these waxes are being morphologically changed to amorphous rather than crystalline. Crystalline means it's a crystal structure that can deposit out. Yeah, deposit out. Amorphous mean the structure is difficult to become a solid. So that's why these inhibitors are currently researched. Yes, actually wax have a lot more the solution. Wax and scale is lots of solution available on the ground.
Mhm.
Next year.
Thank you. Thank you. Very good questions and very good answers. The next question is more towards like how do we prevent formation damage? In particular, one of the participants would like to know what are the factors that can minimize the depth of formation damage?
Okay, very good question. I think it's kind of like good sum up of the presentation, right? Thank you for that question, whoever that asked me. Now, formation damage is something that you cannot take away actually to be exact. Yeah? So, but you can minimize. What is the difference? The last thing we want to do as engineers is we don't pay attention to certain type of what is how you design the well and operation, and what are the system you have in place in your philosophy of operating the well and the field is missing of the type of formation damage potentially can happen. An example will be, and let me give an analogy also. Now, if you have diagnosed with cholesterol, right? You're diagnosed with
Yeah.
cholesterol, and you know that you're dealing with it, and the last thing you want to do to yourself is, if the cholesterol is bad lah, now there's a contemplation going on that the cholesterol is not bad after all, but I'm going to take it away. US, United States Food Agency said something else. So I'm going to take that factor away for a while, guys. So assuming that cholesterol is bad to you and you already know that, what do? There's two approach, right? Do you continue to eat food that can contribute to your cholesterol, or you change your dietary? That's question number one. Question number two, in your daily physical life, that means your movement, your motion, do you change your habit? Means that, say, you never participated in sport, you're not interested. Nothing wrong with it. But the point is, are you going to change your habit a little bit now? So is it important or not? So that is the kind of thing you must, and the analogy to your field. Now, the last thing you want to know is you already have all the expert, giving you the right advices, but you continue to ignore, and you do not anticipate also, being too naive that, okay, we have horizontal well, we have lot problem for hole cleaning. So at the drilling section, can we actually spend additional 1% to make a drill, sorry, solid free drill in fleet, because we don't want to control the solid issue. And you say, no, I'm a drilling engineer, I only care about my KPI. I want my AFE to be controlled. So I just want to stick to what I decided. The rest we can tackle later in production. This is the kind of conversation telling that what is lacking in the organization. This is not the kind of conversation we should have. We should immediately emerge with the team members of production technologies and so on, talk about the budget, and management should be able to support you guys, support us, because this small incremental $100,000 bill can contribute to 20, 30, or $100 million loss in a well. So that is real, guys. This is I've seen, I've been in the team, I had heard this conversation, and I've seen the result. I'm telling you, we cannot afford to do this, to work in silos where the drilling engineer only talk about drilling cost. And then completion engineer only talk about completion cost. The next thing okay, we do will test, we pass on. If we have a damage or skin, and then the production guy can tackle. I think only in the recent 5 years, the completion engineering team now have a KPI to ensure that the productivity is really passed on, and anything that can be done in the completion can be done, right? So that I'm seeing that a lot from completion team. I think I really have to congratulate them. But in the drilling practice, of lots of things can be changed. Now let's talk about production engineering also, right? In the production engineering, some of the common one I said, we have we know that certain wells are compromised in terms of productivity. So we have annual budget every year. We make annual budget every year, make available to treat the wells, for example. So in terms of prioritization of the well, we often compromise. I've seen this, but not to criticize, but I think I just want a good one to come up, right? So we prioritize based on gain. I am not sure, honestly speaking, whether there's a right strategy. If you ask me, the way I will do is, even though I rank it prioritize based on gain, I will also prioritize based on prognosis and diagnosis. Which well is understood for what, and how much confidence level we have that we can remediate. Because at the end of the day, it's not about how many wells we treat, it's about how many wells we are able to revive, how many wells we are able to produce more. That is the final result we want to see. It's not about, okay, we see this potential in paper, it may look good too, right? So that is the kind of thing that we saw in the case study that we presented just now. It's a classical example of how you can prioritize both based on the prognosis that you already well understood. The data set really support your theory. At the same time, your gain is quite substantial because you already know technical potential during your completion stage. So that too must corroborate. And the last thing is, of course, based on, marketing is obviously, you can't blame, because as a innovators, as technologists, as a company with a forefront of innovation, it's their job to promote the technology. Nothing wrong in that. But it's our job who choose the technology to ensure that we, in turn, understand very well, the applicability and how we, don't choose technology to the well, Start with the well first. Start with the well, understand the problem, understand the diagnosis process, understand the progresses, then go after the technology. Do not just based on, this is the latest technology, let's replicate. It doesn't work like that. If you try to start from the technology, match the well, it's a bit of a problem. So start with the companies, or start with consultant or experts from even the company who provide products. Also, okay, sometimes they are able to demonstrate impartial views, a neutral based view to tell you guys that what is actually the problem first. Then go and match the technology. Do not work the reverse side of it. I've seen very commonly people do the reversing, okay, I have a very good technology, just rolled out and, just came out from GOM, Gulf of Mexico. And let's see where else is applied. It doesn't work like that, actually. That is a major problem we have. I think Terry is smiling, something he probably reflect. I think that's my ideology about formation damnation. Anything else we have?
Okay, I think we are approaching to the end of the time allocated. Let me just quickly wrap this up. Yeah. So we would like to apologize again if we are not able to, take in any more questions, but don't feel despair because we will address the unanswered questions through the follow-up emails that we will send soon after this webinar.
Yep, I
Just
think.
before, yes, just
Mm,
before we break, and let me just give you a few
yeah.
more information. On behalf of Invigour Energy and also Reservoir Link, we'd like to share some of the future webinar and upcoming training courses that we will be putting together. Firstly, we will be having a free webinar on the 11th of September on how to basically introduce oil field production surveillance data analytic using the software Invigour Reservoir. And next, we'll be also conducting an online industrial training courses for 5 days on production technology for other disciplines and also gas lift operations and optimizations.
Yep.
Yep. If you are interested to register or have any further inquiry, feel free to visit our website and also, just send us any email or speak to any of our team member.
Please
So
snapshot this slide, very important because I know that some of you would like to try to connect to me directly. This is how you do that.
yes, exactly. So we have come to the end of our webinar. Keep a lookout for our follow-up emails that will alert you at the end of the today's webinar. And you can also review the material that we will send out so that you don't miss out any information during the webinar. And also, please take a moment to fill up our short survey to help us to improve, in our future webinar. I would like to remind you again, do not feel hesitate to email us for any inquiries as displayed on your screens right now. So again, on behalf of Invigour Energy and Reservoir Link, we thank you for joining us today. Don't forget to fill up the feedback forms that you will see after this webinar. We hope that the session will benefit your careers and your educations. And again, my name is Terry. Have a good day and goodbye. Thank you.
Okay, see you all again. See you in LinkedIn. Thank you, all of you. I really appreciate your participation. Great question, great participation. Very importantly, remember, knowledge will empower you.
Exactly. Yeah. Thank you, Anwar. Thank you, everyone.